Kemudian kita akan letakkan point dia kita boleh tempat yang betul kita ada negatif 4 ini ada point itu masukkan dengan umur yang lebih kecil di sebelah kiri so, bila ada 2 point kita ada 3 kawasan kawasan kita ada simbol apa jari-jari di bawah foto. Ya, dance circle. Ini kita akan buat dance circle ke empty circle sekali nak tutup. Kita akan buat empty circle di mana kita samakan apa aja buat tadi nanti ada kawan-kawan buat kat sini. Buat dance circle. Masih dapatkan bentuk baru lewat sini. Lewat sini. Maknanya nanti jawapan kita tidak akan termasuk dalam tempat lain. Okey. Kemudian kita lihat origin dia. Ini nombor 4. Sebelah ini kita X. Apa nilai yang paling sesuai yang mudah kita ambil satu nilai kita nanti cepat. Nilai apa yang kita pilih? Negatif 5. Okey. Boleh pilih satu nilai yang sama di sebelah kiri. X negatif 5 gantikan padanya Anjir. Congratulations.
Apa cikgu?
Bagus tu. 100 orang.
Oh, tu.
Cikgu pun baru semalam cikgu join.
Okay, yang kat Zoom itu dengar tak? Kalau dengar boleh komen sikit. Dengan kat YouTube itu kalau dengar boleh cakap good morning. Do you hear me, class? Dengar ya, tapi itu. Okay, bagus. Yang kat YouTube itu dengar tak? If you can hear me, please wish good morning. Okay, Atika, good morning. So I know that you all can hear me. Good. Good morning, Karata. Good morning, Lingus. Okay, this is the answer which I show for yesterday's quiz. Okay. So if you want, you can actually try and see. Okay, good morning, Alia. Good morning, Chu. Okay, so I really hope that you all can hear and can follow lah. Okay, soon we are going to discuss about binomial more, and we try to finish up binomial today. I wish you can take some notes first, so I hope you can take out a few A4 papers to be ready for you all to take notes. Okay, while we wait for your friends to come in, just hold on for a while. Okay, that is the answers there for the 40 minutes challenge which I gave you all yesterday. Congrats to the one who managed to top the whole Malaysia matrix. Congrats. Okay, for those who did not manage, really hope the next time you can try lah. Okay, and can do. Okay, try to inform you all a little bit so you all will be on track. Congrats lah. Leka was the most amount of people who enter. That was good. That shows that you all are interested to study lah and prepared to do your exam soon.
let F equal to negative 7 or calculate function and for this equal M is a right ada dia kita buat saya dalam bentuk interval Jadi cara kerja menggunakan underline kita cara sama dengan
Okay, I'm waiting for your friends to come in, and once sharp 10 o'clock, I will start. Okay, so please do advise them to come in fast. Okay, for those in YouTube, if you can hear me, you can say yeah. You can say let's begin. You can say whatever positive words you would like to wish. Not only to me, but to your friends out there. Anybody's birthday, then maybe you can wish them happy birthday. Okay, those in Zoom can hear me clearly, right? Any problem? Okay, Tan Yun Si, can you hear me? Those in Zoom, can you respond back to me? Can you all hear me or not? Because there is no response yet. Hope all of you all can hear me.
Yes, sir.
Can, okay, that's good. Hope that next time y'all can be a little bit live. Okay, we got 2 more minutes, then I start live. Those in YouTube, y'all can hear, right? Any problem? Let's begin. Okay, yep, 2 more minutes time. I begin, Hatta. Okay, thanks for confirming that you can hear. Thanks for confirming that. Okay, Angelia, have a nice day too. Okay, Deviana, congrats to you. Yesterday you managed to become one of the top. Okay, good results over there. Please keep it up, lah. Good morning, Fatin. Good morning, Michael Yan. Always remember, we should compete with others, not only in our college, but also outside of our college. So it was nice to see yesterday many of you all took the 40 minutes challenge set by Mr. C.K. Tan. Okay, he's from a lecturer from Selangor. He set the thing, and it was a good practice for all of you all before you attempt your UPS 1. Okay, before you attempt your UPS 1. So it's quite a good practice. And here are the answers. The questions I did give you all in the Telegram group also. Okay, so good luck. As I told you all, practice makes perfect. So sometimes I give you some questions, and sometimes other lecturers give you questions. Just do, that's all. Okay, the mission is to do and to be the top. Okay, Muhammad Fidaus, good morning. Nurul Hafiza, good morning. Ahmad Rafiq, good morning. So we are going to start soon. Hopefully we can start right now. Okay, so in 30 seconds I start. you all can respond back lah. Okay, and let's begin today's class lah. Okay, so yes, last class I stopped the lecture 9, I think. I stopped at type 1 of expansion of binomial expansion. So now I'm going to go to type 2 lah. Okay, now we are going to go to type 2. So under type 2 here is also going to be more interesting. Let's see the questions over here. Now I'm going back to the slides which I use, okay, because I feel that the notes over here will be better lah, okay, for type 2. So let's begin type 2 here, okay. Now under type 2 here, we are not going to use the NCR expansion anymore, okay, but the formula comes from there. Okay, the formula comes from there. If n is positive, okay, I also can still use this formula. Okay, the formula is a very simple formula. If 1 plus b power of n, such that, okay, in front here must always be 1. The green color highlighted part there must be 1. Okay, so our formula will become 1 plus with n, okay, b power of 1 over 1 factorial. 1 factorial is 1 lah. So if you never write also is okay. Understand? Then plus with n minus 1 b power of 2 over 2 factorial plus with n minus 1 minus 2 b power of 3 over 3 factorial. So if you notice one thing, what is going on over here, the highlighted part over here, okay, this highlighted part, this part here, okay, is actually your NCR. Actually, that is your NCR over there. Okay, but NCR only can apply when the n are positive integers. Okay, when there are positive integers over there. So since now, let's say if n is positive or negative, sorry, I would put here negative lah, better. Okay, negative integers and fractions. Okay, and fractions, then we will be using this formula still, 1 plus b power of n. But remember that in front here must always be 1. Must be 1. Okay, the formula remains the same, 1 plus n b power of 1 over over 1 factorial plus with n minus 1. Okay, b power of 2 over 2 factorial plus with n minus 1 minus 2 b power of 3 over 3 factorial plus so on. Okay, and this is infinite. This is infinite. Why infinite? Because you cannot stop. Understand? You cannot stop. Like if n is positive, then we can stop until power of 7, until power of 8. Yes or not? We can stop. But this is infinite, so we cannot stop. Okay, so in this case here, we'd say that the modulus of b must be less than 1. Okay, such that the modulus of b is less than 1 for it to be valid lah. Okay, the expansion is valid if modulus of b is less than 1. Okay, or we can even write down here the expansion is valid. Okay, such that expansion is valid for modulus of b less than 1. So b is less than negative 1 and 1 over here. Okay, so that is the formula which is given. Okay, that is the formula which is given, and we use this whole formula over here. Okay, maybe I highlight in yellow. We use this whole formula when the thing is negative integers or fractions. Okay, when the power is negative integers or fractions over there. The n power there must be a negative integer or fractions. Okay, so let's see one example over here. We have 1 plus x power of 1 over 4. So we know that this is a fraction. So we cannot use NCR. NCR not allowed lah. Okay, not allowed to be used already. So if NCR is not allowed to be used, so we know this is 1 plus with, okay, 1 over 4 x power of 1 over 1 factorial plus with 1 over 4, then 1 over 4 minus 1 over 2 factorial x power of 2 plus with 1 over 4, 1 over 4 minus 1, 1 over 4 minus 2, then x power of 2 over 2 factorial plus with dot dot dot. Okay, because it's infinite. Okay, and the expansion, before I can write down the expansion is valid, let's expand this first. So I get 1 plus 1 over 4x plus with 1 over 4. 1 over 4 minus 1 will become negative 3 over 4 x square over 2 plus with 1 over 4 negative 3 over 4, and then 1 over 4 minus 2 is going to be negative 1 3 over 4 lah. Okay, x square over 2 factorial, sorry, 3 factorial, my mistake here, should be 3 factorial here because x power 3, right? So 3 factorial. Okay, x power 3 here. So this is 3 factorial. Okay, 3 factorial is 6 lah. So now I can calculate this 1 plus 1 over 4x plus with, okay, can you please calculate this for me? 1 over 4 times negative 3 over 4 divided by 2 there. I'm very sure you get negative 3 over 16 divided by 2 is 32 there. So x square lah. You can see that. Okay, 16 times 2 there. Okay, this will become positive again. 1 over 4 negative 3 over 4 negative 1 3 over 4 there. So can you please calculate that? Calculate for me 1 over 4 negative 3 over 4 and 1 negative 1 3 over 4. What do you get? Anybody can calculate, please? So here you get 1 over 4 times with negative 3 over 4 times with negative 1 over 3 over 4 there, and then you divide by 6 there. So I'm very sure you get 7 over 1 to 8 x power of 3 dot dot dot. Okay, such that the expansion is valid for the B there is 1. So the B there is 1. So you can write down there modulus of x, means in front of the x there is 1. You can see that the coefficient of the x is 1. Okay, so you know that modulus of x is less than 1. So x is between negative 1 and 1. Can you all understand until here so far? The expansion is valid if, let's say, x is between negative 1 and 1. Okay, the expansion is valid when the thing is between negative 1 and 1. Okay, good, Fairuza. That shows that you are calculating lah. Okay, that's good. Okay, let's carry on some more. Okay, we carry on some more. Let's see if 1 plus 2x power of negative 4. Okay, no problem. Since this is negative, so we have to use the what is this called? The factorial formula, not the NCR lah. Okay, NCR will not work anymore lah. Okay, this will not work. So from here, you can tell me that this is going to be 1 plus, okay, the n is negative 4, 2x power of 1 over 1 factorial plus with negative 4, negative 4 minus 1, 2x power of 2 over 2 factorial. Be careful, is 2x power of 2, the b power of 2. Okay, and then plus with, okay, maybe I should write down here the next line. Okay, plus with negative 4 minus 1, negative 4 minus 2 over 3 factorial, 2x power of 3 there. Okay, I'm just going to expand till 3 power of 3. Okay, because they never tell me anything how much I must expand. So they say the first 4 terms only. So if they say first 4 terms is this lah, 1, 2, 3, and 4. So the same thing over here, 1, 2, 3, and 4. So these are the first 4 terms over here. Okay, if they say first 5 terms, then you carry on some more because it's infinite. So 1 minus 8x. Okay, and here is going to become negative 4, negative 5. Be careful, negative 4 times negative 5. Be careful, there is 2x square. So 2 square will times 4 lah. So 80 over 2x square. And then again plus, be careful again, negative 4, negative 5. Okay, times with negative 5 there. Then you times with negative 6 again and divide by 6 over there. So you get negative 20, then times with 8 over there because 2 cube is 8. So here will become negative 160. Okay, x cube plus with dot dot dot. I hope until here you all get. So 1 minus 8x plus 40 x square minus 160 x cube plus dot dot dot. So you can notice one thing is positive, negative, negative. So I'm very sure you can see that that pattern going on there. So it's valid for, okay, it's valid for, what is the B there? Okay, the B there is 2x, modulus of 2x less than 1. Therefore, x is less than negative 1 over 2 and 1 over 2. I hope until here you all okay. Any problem until here so far, class? Any problem until here so far, class? Can? Okay, now if you want to see the more examples is inside my the other one more note also. I will give you more examples after this lah. Okay, let me finish up the lecture first. Can everybody? If can, then I proceed. I hope you all can let me proceed. Please respond. Understood, huh? Okay, when you shall say understood. So yeah, I think I can proceed lah. Okay, so let's see. We see another one more type here. Here is 2 plus x power of negative 2. So this is what I call type 3 lah. Okay, this is what I call type 3. Why I call this type 3? Because the a is not 1. So if you look over here, this is 2 plus x power of negative 2. And I told you the a must be 1. So if the a must be 1, how to make the a become 1? Or divide here by 2, divide here by 2. But don't forget, take out 2. Okay, take out 2 and bracket up the whole thing here. So when I get that, this is 2 power of negative 2, bracket, 1 plus x over 2 power of negative 2. Can you see that? Why? Because when I take out the 2, okay, this 2 here, the 2 must times with power of negative 2, will be 2 power of negative 2 there. So that's why it remains 2 power of negative 2 over here. Can you all understand that? Okay, so from here, I know that I'm going to get here 1 over 4. Okay, 1 plus x over 2 power of negative 2. Now, as we know that this expansion is power of negative 2, we cannot use NCR lah. So since we cannot use NCR, we have to go and use our factorial method. So 1 plus negative 2 x over 2 power of 1 over 1 factorial plus with negative 2, negative 3, because minus 1, yes or not? Now I can do it a bit faster, right? Negative 2 minus 1 is negative 3. And here will become x over 2 power of 2 over 2 factorial plus with negative 2, negative 3, negative 4 over x over 2 power of 3 over 3 factorial plus with dot dot dot. Okay, now from here I can tell you 1 over 4. Okay, 1, negative 2 times x over 2 then negative 1. So negative 1 x over 1. Okay, then here will become negative 6. Negative 6 times with 1 over 4. Remember, 1 over 2 square. So 1 over 2 square will give you 1 over 4 there. Divide by 2 some more. So I get negative 3 over 4. Sorry, positive 3 over 4 x squared. And then the other one more definitely is going to be negative. I know that. So negative 2, negative 3 is negative positive 6. 6 times negative 4, negative 24. So negative 24 times with 1 over 8 there. So I'm very sure you get negative 3 divide by 3 factorial. So divide by 6 there. I'm very sure you get negative 1 over 2 x cubed plus dot dot dot. But don't forget the 1 over 4 outside there. So the 1 over 4 must times inside now lah. So here I get 1 over 4 minus 1 over 4x plus with 3 over 16x squared minus 1 over 8x cubed plus dot 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 such that expansion is valid for this must always be written line is valid for what is the b? Look at the b there. Now the b is from here. This is the b line. This is the b here, x over 2. Understand? X over 2. Or here, can see this x over 2 there. So we know that is valid for modulus of x over 2 less than 1. Therefore, or you can write down like this, positive 2 and negative 2. Understand? Positive 2 and negative 2. So normally we write down both lah, easier to see that way. Clear? Okay, any question until here so far, class? Any question until here so far, class? If anybody got question, please do ask. Anybody got any question? You can ask. I can hear you, so no problem, I guess. Yep. Okay. If no, then I'm 1. Let's see another one more. 8 minus x power of negative 1 over 3 then. Power of 1 over 3. So since this is power of 1 over 3, it's a fraction. So NCR NCR cannot work lah. So that one you all should know already lah. Okay, so now from there I get 8 minus x power of 1 over 3. Okay, so let's expand this thing. Oh, cannot expand yet because the a in front here, this is not 1 yet. This is not 1. So how to make it 1? Oh, divide by 8 lah. So 1 minus x over 8. Okay, power of 1 over 3. Take out the 8. Okay, here. So now I can take this as 8 power of 1 over 3. 1 minus 8x over 8 power of 1 over 3. 8 power of 1 over 3 is 2. Everybody should know that, right? Okay, bracket. Okay, let's do the expansion a little bit. 1 plus with 1 over 3 negative x power over 8 power of 1 over 1 factorial plus with, okay, 1 over 3, 1 over 3 minus 1. So 1 over 3 minus 1 is negative 2 over 3. Okay, negative x over 8 power of 2. Look, the b is negative x power of 8. The b here right now is negative x power of 8. So I hope until here you are okay. Clear? The b is negative x over 8 then. Okay, then power of 2 over 2 factorial plus with, I try to carry on here a bit, 1 over 3, negative 2 over 3. Yes? Here ada soalan. Asus itu boleh mute kan? Okay, thanks. So negative 2 over 3, then here will become negative 2, 1 over 3 minus 2, yes or not? Okay, 1 over 3 minus 2 there will become negative 1, 2 over 3. Then negative x over 8 power of 3 over 3 factorial plus with dot dot dot. Now, if I expand this really nicely, here I get 2, 1. Okay, be careful when you press your calculator. You press 1 over 3 bracket, close bracket, then open bracket, negative 1 over 8 power of 1. Put line inside the calculator, divide by 1 factorial. You can straight away get 1 over 24x. Then the second one there, you press your calculator, bracket 1 over 3, close bracket, bracket again, negative 2 over 3, close bracket, then bracket again, negative 1 over 8, close bracket, power of 2. There you get negative 1 over 288 x squared. So you press your calculator correctly, I'm very sure you get the answer lah. Everybody can press for the third one. Please press for me for the third one so I can confirm that you know how to press your calculator. Okay, give me the answer. Anybody can give me the answer? Come on. I'm waiting for your answer. Yes, class? Those in Zoom, you can type on chat or you can speak out. I'm waiting for your answer. Yes, can I know please? Alia, Khairil, Mirul, Galden, Heng, what's the answer? For the last part there. Yes, correct. Okay, so if you divide by the negative 1 over 288, I never divide by 2, ma? Oh, yes, I did not divide by 2. Sorry, my mistake. Negative 1 over 288 there. If I divide by 2, I get negative 1 over 7576. Thanks for checking that. The last one, come on. I'm still waiting for the answer. 1 over 13824. That's right. Okay, positive 1 over, sorry, negative. Okay, it will be negative 1 over 13824 x cubed. Okay, why negative? Because if you notice one thing, here is negative, negative will become positive, but power of 3 will be negative. So since power of 3 will be negative, that's why here is negative lah. So here will be negative, negative, negative. So I hope everybody get this answer lah. This answer is given to me by Vanusha. Okay, good. Okay, so if this expansion is correct already, plus dot dot dot, now you have the times 2. So 2 minus 2 over 24x minus 2 over 576 x squared minus 2 over 13824 x cubed plus dot dot dot, such that, okay, the expansion is valid. Okay, expansion is valid for what? Okay, now look at the b there. The b is negative 1 over 8 there. So x over 8 modulus less than 1. So x is less than negative 8 and negative 8. Positive 8 and negative 8. Clear into that? Why? From here, this will become x over 8 is less than negative 1 and 1. So bring up the 8. That's how you get negative 8 and 8 there. Clear until here, everybody? Any problem until here so far? Clear, class? Okay. I hope my calculation is correct. And so far, everybody okay lah. Of course, you can simplify. You go and simplify lah. If you can divide by 2, you go and simplify 2 minus 1 over 12x minus 2 divided by 576 there. It's going to become what? Oh, 1 over 288 and then minus with 2 divided by 824 there. So if you divide that, you get 1 over 6912 x squared x cubed. This is x squared plus dot dot dot. Okay, so I hope until here everybody okay lah. Any problem inside this expansion of type 3 here? Can class? Can class? Okay, so now you know how to expand already lah. So I just summarize this thing a little bit first. Okay, before I move on, let me summarize. Okay, now the summary over here is very simple. You got 3 types. Okay, type 1 over here is going to be a plus bx power of n. Okay, such that n is positive integers. Okay, positive integers. So if positive integers, you know you can straight away use NCR, or you can even use the factorial lah, or you can use factorial method. The next one there is a plus bx, okay, power of n. But this time the a is 1. The a have to be 1. And okay, and here is going to be negative or fractions. Okay, or fractions. Then you cannot use NCR. You only can use factorial method anymore. Understand? The factorial method means n, then n minus 1, n minus 2 divide by the amount of factorial 1, 2, 3. So divide by 3 factorial lah. This will be x cubed. Understand? If power of 3, therefore 3 factorial bx cubed lah. Okay, so this is the method which we have to use. I call this factorial method lah, the factorial formula. Clear? The next one there will be a plus bx power of n. In this case here, you have to divide this by a, divide this by a, take out the a, put power of n. And also over here, the a power of n, 1 plus b over ax, power of n here, such that the n also over here is for negative and fraction only. Negative or fractions. If over here, no problem. If n is positive, you even a here is 3 or 4 or 5, you don't need to divide by a. Understand? You can straight away proceed, no problem with that. Clear? But over here, cannot. The a, you must divide and factorize the thing first. Simplify the thing first. Then from here, we have to write down is valid for lah. Is valid for b over a modulus b over ax less than 1. Over here, so we have to write down valid for. Okay, in this case here, we have to write down is valid for bx modulus less than 1. So that's what how I break up into 3 types. No? This is type 1, type 2 there, and last one here is type 3. Any problem until here so far, class? Can? So I try to summarize for you all so that you know what to do after that. Any problem until here, class? Can? So far? Okay, Kana Hata. Okay, Shafika say can. The others, are you all okay? So far can? Okay, Kana. Okay, so I proceed. Now let's go back again to this type of question again. So once we study the type already, now we want to find the term. So let's say if they give me the term over here. So now determine the general term in a binomial expansion. So now I want to determine the term. Okay, so we know already the type of expansion, what, right or not? So of course, one way to determine the term is expand everything and then find which term is it lah. But if they give me 10 power of 10, 2 plus 3 power of 10, if I want to go and determine the 6th term, it's going to be very hard. I have to expand everything until I get the 6th term, then I can give you the answer. So instead of doing that, they come up with these 2 formulas here lah. Now the formula which I like to use is this one. You don't need to remember the both formula. You can remember any one of it. Okay. The only difference is one is TR, one more is TR plus 1. Okay, so R there is the NCR there. Okay, R there is the NCR. So if I use the sixth term, I know that T6 is can be written as 6 plus 1 or 5 plus 1. So I know that this is NC5. The A there, since they say is ascending power of x, so the 3x will become my A, which is power of 5, and the 2 there will be the balance lah. So I know the n is 10. So the balance there will be 5 there. Of course, some of you might ask me, so the A and B, I can change position. Yes, correct. You can change position, no problem. Okay, you can change the position of A and B. The A and B is depends on you, right or not? I can put like this. Okay, no problem. Okay, but normally, since they tell me ascending power of x, I know the x is going to be power of 5. Okay, so that's why I put x power of 5 there, 3x power of 5 there. Why? Because sixth term will be power of 5. If second term will be power of 1. First term will be power of 0. First term is power of 0. Second term will be power of 1. Third term will be power of 2. Sixth term will be power of 5. So if I ask you the 10th term, of course, will be power of 9. Understand? The 11th term will be power of 10. Understand? The 11th term will be power of 10. If it's power of 10, guarantee you will have 11 terms inside the series. If it's power of 12, you will have 13 terms inside the series. Clear? Okay. So from here, 10C5 there, you can calculate, no problem. So what is 10C5? Okay, you press your calculator, 10C5. Okay, you're going to get 252 there. Then 3 power of 5, you can calculate also, no problem. Which you get 243. Then 2 power of 5, you can calculate, which you get 32 there. X power of 5. Okay, so if you calculate all of this, 252 times 243 times with 32 there, I think you get 1959552. Okay, x power of 5 over there. Any problem until there so far, class? Can? Okay, I hope until here everybody okay? No problem? Okay, so if they ask the coefficient, if the term, this is the term lah. If they ask the coefficient of x power of 5, the coefficient is just 1959552. This is the coefficient. Okay, that is the coefficient of the x power of 5 term. Understand? Okay, let's see the next one here. Let's see this one. They say find the term that have x power of 3 in the expansion. Now we don't know. They say they want to find with x power of 3. Okay, now since x power of 3, if you notice over here, what I did was, the r is the power. The r is the power over here. Can see that? Okay, the r is the power. So I know that I can write down the formula which I'm going to use, tr plus 1 and cr. Okay, a here I'm going to put 3x. B there I'm going to put 5 over 2x. It's up to me. Okay, up to me. The n there I know is 5 already. So if this is r, this is going to become 5 minus r. Agree with that? Okay, that is going to become 5 minus r. Okay, so now I can expand out this thing. 5cr, 3 power of r, x power of r, 5 power of 5, 5 over 2, 5 over 2 power of 5 minus r, 1 over x power of 5 minus r. So I break up all the numbers. All these are numbers. All the highlighted part there is number. Red color highlighted is numbers. The yellow color is the x. So the yellow color is going to play a role right now, because x power of r times with 1 over x power of 5 minus r must give me x cubed. Only the yellow color highlighted part will play a role. Okay, so here is r, not r5. So now you know that x power of r times with x power of negative 5 plus r equals to x power of 3. Now compare the index. So 2r minus 5 equals to 3. So 2r equals to 8, r equals to 4. Now if r is 4, okay, they want to find the term. If r is 4, so if I substitute back 4 inside here, I put 4 inside here, 4 plus 1 will become what? 5, right? So the term is going to be, the fifth term. Understand? Is the fifth term. And if I substitute back inside there, I just substitute that. I get t 4 plus 1, which equals to T5, which equals to 5C4, 3x power of 4, and 5 over 2x power of 5 minus 1 there. 5 minus 1 there is, 5 minus 4 there is 1. Okay, because the R is 4. So from there, I can calculate 5C4 using my calculator. Okay, 5C4, which is 5. And then 3 power of 4, which is 81. X power of 4. And then 5 over 2 x. So from there, you can tell me 5 times 81 times with 5 over 2 there will give you the final answer 1012 1 over 2x power of 4. Any problem until here so far, class? Okay, sorry, x power of 3, my mistake here. Because power of 1 there, right? So negative 1, so x power of 3 cancel, power of 3. Can see that, everybody? Any problem until here so far, class? Can accept this? Okay, now Fletcher, we are learning binomial expansion now, Okay, so I hope everybody can explain to him later, Okay, anybody else? Any problems so far? Can? Okay, ada soalan lagi? Okay, let's see lah. Now we see another one more. Now the next one there, they say independent of x. So what is independent of x lah? Of course, independent of x there is going to be x power of 0. Independent of x is x power of 0. Constant also. Okay, constant also is what? X power of 0. Yes or not? Okay, so let's see over here. Again, I use back the same formula, TR plus 1. The A there, this time I use 12 CR. Now, this time I use the A as negative 1 over x power of 0. Power of R. Means the A is negative 1 over x. And the B is 2x cubed, 12 minus R. So I proved to you that we can change, doesn't matter. Okay, doesn't matter over there. So since it's independent of x over there, I know that this is going to be negative 1 or negative 1 over x power of R, which will play a role, and x cubed, okay, 12 minus R, which will play a role over there to determine the x value there, so x power of 0. So to determine the R value, to determine the R value. So negative R plus with 36 minus with 3R equals to 0. Negative 4R equals to negative 36. R there equals to 9. So if R equals to 9 over here, so we know that this is going to be 9 plus 1, which is T10. Okay, T10, the 10th term. Or now the 10th term over here can be written as 12 C10 negative 1 over x power of 10 and 2x power of 3, 12 minus 10, which is power of 2. Okay, which is going to be power of 2 then. Am I right? Okay, R there is 9. Sorry, my mistake here. This is 9. 9. So the R is 9. 9. And 12 minus 9 there is going to give you 3. Okay. So from there, we can calculate this. 12C9. Okay, 12C9 there. All of you all can press your calculator. 12C9 is 220. Then here you get negative 1 power of 9, which is negative 1. And 2 power of 3, which is 8. Of course, here you got 1 over x power of 9 times with x power of 9. So cancel. No more x dealer. So that's how you get 220 times 8 times negative 1, which is negative 1760 there. Any problem until here so far? Anybody got any problem? If you cannot understand, let me know, please. So this is how we find the terms. Okay, and this type of question will come out for type 1. This type of question normally comes out for type 1. Understand? So when it's type 1, we can use this method. If it's not type 1, then you cannot use this method anymore. Means if your n is not positive integers, you cannot use this method anymore. Go back to your factorial method. Understand? Later you will see a few questions like that in your tutorial also. Okay, let's go on some more. Okay, let's go on some more without wasting much time. Let's see this type of question now. Okay, example number 3 over here. So if you look over here, you see here 1 minus 2x power of half. Okay, power of half in ascending power of x up to the term of x cubed. Okay, let's expand lah, no problem. So this is fraction. Fraction, can I use NCR? Class, can I use NCR? Yes or no? No, so I have to use the factorial method lah. So if I have to use the factorial method, no choice already. 1 plus half negative 2x power of 1 over 1 factorial plus half. Half minus 1 is negative half, yes or not? Negative 2x power of 2 over 2 factorial. Oh, they want how many terms? Oh, up to x cubed. So no choice, have to expand some more. Half negative 1 over 2, then half minus 2 there. Half minus 2 will become negative 1.5. And then negative 2x power of 3 over 3 factorial plus dot dot dot. So here you get 1, and then here you get minus 1x. Okay, plus with, expand for me please. Press your calculator everybody. So 1 over 2 times with negative 1 over 2 times with negative 2 square will become 4. Divide by 2 factorial, so negative half x squared there. Okay, I hope my expansion is correct. Please check. Okay, please check there. Times with negative 8. Divide by 6 over there. So again, you get negative half x cubed. Do you all get this, class? Did everybody get this? But remember, this is not your final answer. What is missing over here? Can I know? What is missing over here? Is valid for. Is valid for what? Oh, negative 2x means modulus 2x less than 1. So x is between 1 over 2 and negative 1 over 2. Remember this. Without this statement, this whole expansion is not valid. Understand? You must put that highlighted statement over there. Correct, Ahmad Rafiq? Very good. Okay, very good. That is second type over there. That's good, Ahmad Rafiq. Can see that you are following. Okay, and the others, good. You all answer no also. So you can see lah, you all are following there. Okay, so now the next part there, they say by letting. Okay, let's see the next part there. They say by letting x equals to 1 over 100 in the series, evaluate set 2. Okay, so if I have to let 1 over 100 for the x there, the expansion was 1 minus 2 over, 2x power of half. So if I need to let x equals to 1 over 100, that becomes 2 over 100 power of half. Means I substitute the x as 1 over 100 there. Now 1 minus 2 over 100 there. Okay, 1 minus 2 over 100, I get 49 over 50. Yes or not? Which I get 49 over 50 there. And this is power of half. Okay, power of half. Power of 1 over 2. So that is 7 square root 50. Square root 50 is 5 set 2. Agree everybody? Don't believe? You can put square root 50. All of you all should know already. Square root 50 is 25 times 2. Therefore, is 2 and then 5 plus. Square root 5. So square root 25 is 5. Square root 25 is 5 over there. You can see that, right? So you get 5 set 2 there. So now you can tell me 7 over 5 set 2 equals to, substitute 1 minus 1 over 100 minus 1 over 2, 1 over 100 square minus 1 over 2. Instead of putting 1 over 100, you want to put 0.01 cube also can. Go and calculate this now. Go and calculate. Press your calculator 1 minus 1 over 100 minus with put 0.5 times with 0.01 square. Press exactly in your calculator. Understand? Press exactly in your calculator. No problem. But right not? Everybody know how to press calculator, right? So you're going to get that in answer form will be 0.9899495. 7 over 5 set 2. But they only want the value of what? Set 2. See? They want the value of set 2. So let's make set 2 the subject. So set 2 equals to 7 over 5, 0.9899495. Okay? So from there, you can tell me this is 7 divided by 5, or 5 times answer first, then 7 divided by the answer. So here you get 1.414, 4142135, but they want in 5 decimal places, so 1.414 0.21. They want 5 decimal places, right? Yep. So I get the final answer here. Can you all understand until here so far? Can follow? Any problem to follow until here so far, class? Anybody cannot follow until here? If cannot follow, please let me know. All can follow? Hello, class. Respond. Can. Okay. One person answer can. The others can follow or not, class?
Can.
Can. Okay, good then. Good. Okay, Kiranya. Good. Okay, so since you can follow, we move on some more. Okay, now the balance question there is here. So we look into last time I gave you all the discussion. Just give me a second. Where is your topic 3? Yes, here. Okay, so if I look into your topic 3 here, the geometric, that one all you all can do yourself lah. Okay, this document is quite heavy already, that's why. Okay, we look at few questions over here. We try and see we can try and do together or not. Okay, let's see this type of question number 8 here now. Okay, we look at number 8 here. So now first thing you need to ask yourself is this type 1 or type 2 lah? Okay, is this type 1, type 2 or type 3? So they give you in the binomial expansion 1 plus kx power of 6, where k is a constant. Okay, the coefficient of x cubed is twice as large as the coefficient of x squared. Find the value of k then. So of course now you know that this is coefficient of x cubed, and then one more is coefficient of x squared. Okay, so if I really want to find the coefficient of x cubed over here, this is going to be power of 3. So this is going to be NCR. R there is 3, the N is 6, the A is 1, Kx power of 3. Here is going to be power of 3 as well. Okay, that is going to be the fourth term. And the fifth term over here, sorry, the third term over here, mistake. The third term is going to be C6C2. 1 there still power of 2, power of 4, and Kx here power of 2. Can you all understand that? So they tell me that the coefficient of x cubed is twice as large as the coefficient of x squared. So 6C3 there, if you calculate, 6C3 is 20 times k cubed, which you get 20k cubed lah. Okay, here is going to be 6C2 times with k squared there. So 6C2 there is 15k squared. So now 20k cubed equals to 2 times of 15k squared. So don't you see this will become 30k squared and then 20k cubed. So you can cancel, left 1k there. So k there is 30 over 20, which is 3 over 2, or which is 1.5 lah. Can you all understand until here so far? Can see how we do that? Okay, Hatta asked me why is the term T4 and T3. Okay, Hatta, to be very frank to you, if you look at this is x cubed. X power of 0, okay, x power of 0 is T1. X power of 1 is T2. X power of 2 is T3. X power of 3 is T4. Agree with this, Hatta? That's why lah. Okay, that's why the thing there is T3 and T4 there. Okay. Another one more way you can know that, because this is going to be power of 3 and power of 2. So here is power of 3. Here is going to be 3. So the R have to be 3. And here power of 2. So R is 2. Here must be 4 lah. Can you understand that, Hatta? Okay, okay, very good. So that's one way to know lah. Okay, that's one way to know. So you have to be prepared for this type of question lah. This type of question is more interesting. Okay, let's see another one more. Okay, let's see another one more over here. We look at this type of question here. Here, they say which one is independent of x there. Okay, they say independent of x. And you look over here also, you know that this is power of 8. Power of 8 is type 1, yes or not? Type 1, so we have to definitely use NCR lah. So we know that TR plus 1 equals to 8CR 4x cubed power of R, and then negative 1 over 2x power of 8 minus r. Okay, because you know that the power when you times this, you plus this one and this one have to give you back 8. Okay, so from here you can tell me x 3r, and the other one more will become x power of negative 8 plus r, because the power of x here is 1. Bring up will become negative 1. So negative 1 times 8 minus r will become negative 8 plus r, equals to x power of 0. Why x power of 0? Independent of x. So from there you get 4r minus 8 equals to 0. R there equals to 2. So if r is 2, this is t3. T3 equals to 8c2. 4x, you put 2 inside there, will become 6. Okay, or we go slower a little bit, 4x cubed power of 2 minus with 1 over 2x power of 6 there. So from there 8c2 is what? 8c2 is 28. 4 square there is 16. Okay, and negative 1. Okay, so negative 0.5 power of 6 there. So you get the answer there, 1 over 64. Okay, x power of 6 and then over x power of 6. So cancel, no more x already lah. Okay, so 28 times 16 divide by 64 there. I think you get the answer, 7 there. Can you see that? That's why the answer is 7 lah. So the term is 7 lah. Okay, but if people ask you what is the term will be the third term. Or which term is it? Then it will be the third term. It cannot be T7. It cannot be 7 lah. If they ask you which term is it, then it have to be T3 over there. Understand? The third term. I hope that is clear. Okay, I hope that is clear. Now let's look another one more interesting question. This one I should never do before, so we try to do together lah. Okay, let's look at this now. This is more interesting little bit. Okay, okay, maybe this will give you a little bit idea lah how this thing is going on. Now if you look over here, 1 plus kx power of n, you do not know what is n. Since you do not know what is n is just a positive integer. You do not know more than that. Yes or not? You know n is a positive integer. So either you want to use the factorial method also can, or you want to use NCR also can, because they give you positive integer. Now let's say that they never give me positive integer, so I cannot use the factorial method. I cannot use NCR. Yes or not? So I have to use the factorial method. So let's use that now. 1 plus kx power of n, 1 plus n, okay, kx power of 1 over 1 factorial, plus with n minus 1, kx power of 2 over 2 factorial. Okay, now I have to stop until here lah. I cannot do more than that. 1 plus n kx over 1 plus with n square minus n k square x square over 2. So if you look over here, I can write down nk equals to 40, and the other one more will become n square n over 2 k square will equals to 120. I'm comparing with the equation which is given to me. So you can see that this red color part, you will compare with this red color part, and this pink color part over here, you will compare with this part here. Understand? The x compare with the x square compare with the x squared. So from here, if I really want to solve this thing, I'm going to get n square k square minus n k square 120 over 2. But I know nk is 40, right? So since nk is 40, this will become 40 square. Why? Never mind lah, I go slow a little bit, because this can be written as nk square minus nk k. I break up the thing line just to substitute the nk. So here is going to become 40 square minus 40k over 2 equals to 120. So 40 square there is 1600 minus 40k equals to 240. 240 minus 1600 give you negative 1360 negative 40k. So k is what? Divide by negative 40, then you get k is 34. See? Okay, you will get k is 34. The answer for k here is different. Okay, never mind. Hold on first. If k is 34, now if I put back inside here, Did I do any calculation error? 40 squared there is 160, correct. 12, oh, sorry. This here is 12k square. I missed out the k square here, sorry. So now will become a bit easier, I guess. I have to redo again this part. Sorry, yeah, I missed out the k square. Sorry. Again, I redo. Okay, so if you look over here, k square can cancel. So n square minus n equals to 240. You shift over n square minus n minus 240 equals to 0 there. Use a quadratic equation. 1, negative 1 and negative 240 there. So n minus 16 and n plus 15 equals to 0. So n equals to 16, n equals to negative 15. Reject. If you reject that, you put n equals to 16 there. 16k equals to 40. So k equals to 40 divided by 16 there lah. Yes or not? So 40 divided by 16 there is going to give you 2.5 over there. Can you all understand that? Any problem until there so far? Can class? The important part there is you understand why we are using this method lah. Okay, so you not necessarily you have to use NCR. NCR, yes, you can use when it's positive integer. But the NCR formula comes from this factorial formula. So anytime you get stuck, go back to the factorial formula. Guarantee you can solve any problem. No? Clear until here, class? Okay. I have some more 8 minutes. So I try to do one more question maybe for you. Okay, let's try to do a negative one question. Nah. Okay, maybe I try and do this question here. Let's see. This is quite long. If not, yeah. Okay, let's try and do this one here. Substitution question again. Okay, so I look at this. Oops. My iPad hang already. Hopefully, okay. Can copy. Yes. Okay, I add the page. And I try to paste the thing. Yeah, can. Okay, let's see lah. Here. One more. So if you look over here, infinite terms. So no problem. You can expand this. 1 minus 2x. Okay, 1 minus 2x. This is power of half there. So you know that this is going to become 1. I try to do faster a bit. Half. Then negative 2x power of 1 over 1 factorial plus with half. Half minus 1 is negative half. Okay, then negative 2x power of 2 there over 2 factorial, then plus with half, negative half, and negative 3 over 2 power of negative 2x power of 3 over 3 factorial. So the expansion, no problem lah. You all can go and calculate using your calculator and you all can get this expansion over here. So the answer for the expansion, I leave it to you all. Okay, the answer for the expansion, I leave it to you all. Isn't this the same like just now, I guess? Oh, this is exactly the same like just now. So let's try and see a different question. Better I try and do number 22. Sorry, I did not notice that. Okay. Now, I will leave this. Yeah, this was same like just now. So now, I think infinite series to expand until x cube, no problem. You all get ready. Fx equals to, or instead of writing fx, you can tell me that this is 20. 4 plus 2x, power of half here, power of negative half. The 20 will remain as 20. The 4 there must divide 4. So it become 4 power of negative half. Okay. 1 plus 1 over 2x power of negative half. I hope until here everybody okay. So 4 power of negative half. 4 power of negative 0.5 there will give you half times 20 there will give you 10. So 10, 1 plus 1 over 2x power of negative half. You can expand this, of course. 10, 1 plus with negative half. 1 over 2x power of 1 plus with negative half minus 1 there, negative 3 over 2 half x power of 2 plus with negative half, then negative 3 over 2 and one more minus 1 there. So negative half minus 2, yes or not? So negative 2.5 lah. Okay, and then half x power of 3 over 3 factorial. This one must be over 2 lah. 2 factorial. Okay, and of course you can expand this. If you expand that, don't forget the validity. It's valid for what? Okay, valid for half x modulus less than 1. X is between negative 2 and 2. Okay, so make sure you write down that. So, yep, that's right, Haka. I corrected the thing there. Correct or not? I put 3 factorial there and this one ready. So, correct, right? Okay, good. Then you expand out the thing. You will get the final answer there. 10 minus 5 over 2x. Okay, plus with 15 over 16x squared. And then minus with 25 over 64 x cubed. Now this is equivalent to 4 plus 2x there, power of half. Okay, that is equivalent to 20 bracket 4 plus 2x power of negative half there. Now they want to get square root of 6 by substituting 1 over 12. So let's substitute 1 over 12 lah. So if I substitute 1 over 12, I get 20, 4 plus 2 over 6, 2 over 12 there. Okay, power of negative half. So if I calculate this thing, I get 20. Okay, 4 plus with 1 over 6 there, it's going to become 25 over 6, power of negative half. I can write back this as 26 over 25, power of half. Because if I upside down the 25 over 6, will become power of negative 1, yes or not? So negative 1 times negative half will become power of half lah. So from there, you can tell me this is 20 over 5 square root 6. That is equivalent to this expansion over here. You can put this expansion over here, right? Not? Okay. So you can write 20 over 5 square root 6 equals to 10 minus 5 over 2x plus 15 over 10x squared minus 25 over 64 x cubed plus dot dot dot. Since I put 1 over 12 inside here, okay, I did put 1 over 12 inside here, right? Inside the x there. So I must put 1 over 12 inside all of these x lah. So let's put lah 10 minus 5 over 2, 1 over 12, 15 over 10, 1 over 12, square minus 25 over 64, 1 over 12, power of 3, dot dot dot. So now I times by 5, divide by, or cancel, here you get 4. So square root 6 equals to the answer divide by 4 lah. So what is the answer there? Go and calculate using your calculator again. 10 minus, press exactly the same lah. Just press your bracket, press your calculator with bracket. Remember, press your calculator with bracket there. If you don't want to press fast, you press slowly, one by one. Okay, 1 over 12, power of 2 there. Hopefully, I never press wrongly and save some time. 25 over 64, and then 1 over 12, power of 3. Yeah? Okay, so I get 9.8018 there. 9.8018572. Divide by 4 there, you get 2.45046. If you take square root 6 also, you will get nearly the same answer lah. Not exactly the same, but nearly the same. Okay, 2.4 something. So they want this in 2.45. Yes lah, correct lah. So I get approximately 2.45 there. Can you all understand until here so far, class? Oops. Can you all understand?
Teacher, must we write the sign of the approximate?
Yes lah, because they asked to show what. So you have to write that and write down the word shown there lah. Okay, write down there the word shown. Okay. Okay, so I hope until here no problem lah. Okay. Jining, I will do 24C later in tutorial class. Is that okay? Because I think it's time's up already. You have a next lesson, so I have to stop here today, right? Okay. Thank you, class. I will not take much of your time. Bye-bye. See y'all later. Okay. Bye-bye. Okay. Thank you. Okay.
Thank you, sir.
Okay. Thank you. Mm-hmm.
denominator is